Hi, for this lecture, we want to talk about getting data into your machine. So this is, of course, the very first step that we're really going to have to go through when we go on a project using data. Now, I'm taking Spyder, a Python package, Python IDE for this project. Now, how did I get this on here? I went and I downloaded Anaconda from the web, and then Spyder came along with it. I feel like Spyder is probably the best way for us to start out learning about data. So I'm going to start going over it with this. So what we need to do is, first of all, you have to get Python onto your computer. It doesn't matter which version of Python you're going into, because we're not going to get that deep in this class. This is an introductory class, so we're not going to go into the crazy elite cutting edge aspects of Python or of data science. We're going to emphasize the fundamentals. These are the stuff that you need to know to have a solid foundation to go on and be successful. Now, go get Anaconda and then get Spyder and then start working on stuff. I'm going to put whatever I do in this class, I will go ahead and post that to Canvas, so that way you'll be able to recreate what I did. So what I want to do, I want to show you some code about that shows uploading the Titanic data set from Kaggle into our machine, into our workspace. So first thing I want to do, all right, so over here is my code. Now, what I could do, I could run the whole thing as once and everything will execute at one time. Since we're teaching, what I'm going to do, I'm going to go through, I'm going to go line by line, I'm going to explain what I did, how I did it, why I did it, and hopefully this will work out pretty well. Okay, so first thing I want to do, I want to tell Python where to look when I want to pull some data, where I want to save some data. So what I'm going to do, I'm going to set up what's called the working directory. So if I look here, first I import OS, that is a collection of functions in Python that handle working directories very well. And on this machine, I'm going to press F9, that does one line. So you'll notice I hit F9 when I was at line 3, and it executed over here. It says, hey, it imported OS. Sometimes if there's a problem, you'll get an error message right here. All right, so now what I want to do, I want to look and see what is my current working directory. Okay, so it might have been what I wanted already. Maybe it wasn't. It's good practice, if it's feasible on your project, to have your working directory be central to where you're going to be working. So here we can see that it's in the C drive, users, and ID number. All right, so now what I'm going to do, so you see this OS dot, that means I'm going to call the function from the OS collection of functions. I'm going to go change the directory, and I'm going to say, this is the file path to my working directory. So it's going to be the C drive, users, ID number, desktop, and then the folder where I'm storing everything for this class. All right, let's see what happens. All right, so I'm on the line in Spyder. So I'm on the line. I press F9, and now it executed. Something that you'll notice is when I put these hashes here, that tells Python it can print it, but it ignores anything that goes to the right of the hashtags. That way I can write down why I did something, and it's not going to disrupt the code. All right, so now let's take a look. Did this work? So one thing that in the past I've had problems with students, they don't check to make sure that what they did worked. They just kind of run the code and hope it works out. Every time you do something, you want to double check it worked in data science. This is very different than a lot of aspects of computer programming. I find that professional computer programmers tend to type out code and run the whole batch. Well, in data science, it's more of a fluid process, my feel is. And so we do something, we check it. We do something else, we check it, and we find, oh, wait, things didn't work out the way I wanted to. I have to go back to the beginning. And there's a lot more go forward, go back, go forward, go back in data science than I think in other computational fields. So on every step, you really want to double check to make sure that it did what you intended it to do. Okay, so now what this has done so far, all I've done is I've told the computer where am I storing things and where to look when I want something to happen. Where do I want you to find, where do I want Python to find the files, where I want to find my data sets, and where do I want to record things and save things. All right, so now let's go ahead and actually load a data set into the computer. So in Pandas, this is like the standard way for loading a data frame into Python. This is by far the most common way. And if you want to know more about Pandas, this is the website. Notice the hashtags says it's not going to change anything about the code, so I can do this. All right. Now, I'm going to go ahead and import the Pandas. Now, something that you'll see here is I'm importing the collection of functions I want, and I'm going to abbreviate it that way down the line as I'm typing, I don't have to type out the word pandas every single time. I can save a little bit of space. So I put import the collection of functions I want, then I put as the abbreviation I want for it. Now I'm hitting F9 on my machine. All right, now it does that. Okay, so now let's go ahead and actually read in the data set. Okay, so I'm going to do this. I'm going to hit F9. Oh, wait, whoa, what happened? What happened? There's a syntax error, unexpected EOF while parsing. Okay, why did this happen? What I need to do, I need to highlight the whole thing and press F9, and now it read it. All right, so there is a convention when I do programming is that we don't want to get things too wide, and we don't want to have too many things on one line. So I try to break it up. When I'm reading in a more complicated CSV file, it's comma separated values. When I'm reading in a data set, there are going to be function parameters I'm going to be putting in, and they're going to appear here. So let's say, like, I wanted to skip the first row. So I'll say skip 1, something like that. And maybe I could do header equals false. And then here, I can change parameters. I can change how the function works to make sure that it fits the situation that I'm in. But in this situation, I don't need all that. So I'm getting rid of it. But now we have the Titanic data set is read into Python at this time. All right, so I just did something. I want to make sure it actually executed correctly. So what I'm going to do now, I'm going to check to make sure that it loaded. What's going to happen is, you see I've got Titanic.head and then open close parentheses. What this part is saying is that I want to take the Titanic data set and I want to take the top of the data. So how the data is stored is I have a whole bunch of rows and columns. Rows are horizontal, columns are up and down. If you can't remember, columns of a building are up and down, right? You know, think about like a ancient Greek building. They had the columns going up and down. Roman columns go up and down. So rows go in the other direction. Okay, so head just takes the top of the data set, and tail takes the bottom of the data set. And then the print command says to print it. So what this does, this part says the object that I want to pull is the top of the Titanic data set. This is the object is the bottom of the data set, and the command is to print each of these. Let's do that. All right, so we can see that we got the top 5 rows of my data set. Now, it couldn't print the whole thing, so what it did, it printed the first 3 and the last 3 and put some ellipses in the middle. This way, this gives me a feel for what I have. It doesn't, you know, I'm not seeing the whole thing, but I can verify that it looks like what I want to happen. There's something I want you to notice really quickly. My first row, what number does my first row have? That's a 0. Oh, hey, why are we starting at 0? It makes sense if you've looked at sequences and series from Calc 2, but it's kind of unintuitive for data science, honestly. R doesn't do this. I prefer the other way, but it starts at 0. So we always need to remember our first row starts at 0, our second row is 1, our third row is 2, and so on. All right, now let's take a look at the tail. All right, so now it gave me the last 5 observations, the last 5 rows of my data. And so it says that this is the 1,308th row of my data set. But remember, we start at 0. So there are actually 1,309 rows of data. So we always need to be mindful of that when we pull our data, that indexing starts at 0 for much of Python. Okay, well, let me go ahead and open this up, and let's see. I'm going to show this in a little bit more friendly way to look at it. Here's the original data in an Excel format. And we can see all the data as it is. So these 3 printed. These 3 printed when we did the head command, but name, sex, age, sibling, spouse, parent, children, and ticket did not when we did the head and tail command. All right. So it's good to just have an idea of what data you have. When you get into larger data sets, really you don't look at your data very much, because if I have 10 million rows of data, I would spend the rest of my life looking at it. I would never complete my project. Okay, so now let's go ahead and let's do something a little bit more interesting. All right, so here we are working with pandas. Pandas is by far the most common standard way to have a data frame stored in Python. Another way to store data in Python is with a NumPy array. And depending on what you're trying to do, you need to be able to work with either one. So just as a first look at NumPy arrays, we're going to go ahead and store. We're going to take the data from the Titanic data set as a data frame, and we're going to take it, we're going to take that data, and we're going to create an array with the same data, but we're not going to really do anything today with it. That will come later. So here's what I'm going to do. I'm going to take Titanic.values. So this values, when I apply to the Titanic data set, will create an array, and that will work out with the NumPy array. So a lot of the mathematical functions that you will need for your analysis in Python need NumPy arrays. All right, so let's see what happens. F9, all right, and then F9. And we can see that if I print the type of object that the array is it's a NumPy array, and the ND is a specific type of array. Okay, well, that's interesting. That's nice. But I'm here to be doing some analysis, some statistics, stuff like that. This is an STA class, right? So let's go ahead and let's make some visualizations of our data. What we want to do now, we want to do the basic histogram. So the matplotlib.pyplot is one of the most common ways to visualize data in Python. So that's what I'm going to use. It's very common, very well known, very robust. So I'm going to import it. And notice that I abbreviated it as PLT. That's a pretty much standard abbreviation. Now, what I'm going to do, I'm going to take the pandas data frame, histogram, pandas data frame, create a histogram using the Titanic data set, and I'm going to take the survived data. So if I look here, when we look at survived, it's a 0 and 1. 1 means they survived, 0 means they died. So let's see what happens. And so you'll notice we don't see anything. So let's go over here. Let's go to panes, and I want plots. So Control Shift G. There we go. Yeah, Control Shift Z. So view, and you'll notice that it said plots, Control Shift Z, and it pulled it up for us. Okay, so now we can look and we can see that over 800 died and about 500 survived. Now, also, by the way, this is not the full and complete record of the Titanic incident. This is just what was on Kaggle. There are missing observations in this data set. Okay, well, let's see. Let's do something a little bit more interesting. You notice that it's best practice when I create a visualization is I start labeling it so that the reader knows what they're looking at. This is especially important if you're presenting data results to decision makers because they want to know what they're looking at. They don't want to have to ask. So let's go ahead and let's do plot label, make it survived. Let's do XY label count, and let's do plot show. There we go. Highlight the whole thing, press F9, and it runs beautifully. And I can see that I've got count, I've got survived, and I've got my histogram going right here for us. All right, now let's do it again. This time we're going to do it for the passenger class. Okay, so we can see that we've got first class, second class, third class. A little bit over 700 were in third class, and then about half of the remaining, roughly speaking, were in second or first class. Kind of interesting. Now let's go ahead and take a look at age. Oops, that's not what I want. I pressed F5 instead of F9. That is okay. Age, there we go. So we can see the age of the passenger. So it looks like most of them, around 20 years old was the most common, and then it progressively decreases as we get older and older, and there were children aboard. If you run an analysis on surviving and age, you're gonna see that being younger was advantageous, being female was advantageous, and being first class was advantageous. So if you're a third class male, and you're older, don't go back in time to the Titanic. So I'm not going to go back in time to the Titanic, by the way. I will avoid that. All right, so now let's take a look at number of siblings or spouses. Here we go. And we can see that the majority did not have a sibling nor a spouse with them because we have it at 0. And then as we get a larger numbers, it got fewer and fewer. So siblings and spouses, you can kind of think of them as like equal footing in a relationship. While when we talk about the next one, the P arch is parent, how many parents or children did they have with them on the ship? And we can see that most had 0, the vast majority. And then as you get larger numbers, the frequency decreases. Let's take a look at fare. All right, so when you think about it, what was the most common passenger class? It was third class. And then we have about equal 50-50 on first and second. So let's see what we get when we hit this one. Okay, so a lot of people paid very little, and then everybody else, you know, there's just a few people that paid more, and just a few people paid a whole buttload of money for their fare. Okay, so at this point in the class, what we need to do, we need to get Anaconda onto our machines or get access to some other Python system. Then you need to go through, and I want you to take the files that I put in Canvas and repeat what I did today in this video. That way we can kind of start working on stuff. I hope you have a great day and take care.